Hey everyone, it's Miss B, and in this video we're looking at the Unit 2 Lesson 3 practice problems for Illustrative Math Algebra 1. So this one was about it's linear functions basically and creating equations based off of some situations. So this first situation we're given has a landscaping company that is delivering crushed stone to a construction site. And this table shows the total weight in pounds of W of n number of loads of crushed stone. And then they want to know which equation could represent the total weight for n loads of stone. And so they're just giving us some input and output values here. These are the number of loads, and this is the total weight in pounds. So obviously, if they don't deliver stone, there is no weight of stone delivered. But it looks like one load is 2,000. And then we have two loads being 4,000 and three loads being 6,000. So as we increase here by one each time, it looks like we are increasing by 2,000. So that says to me that each of these loads weighs 2,000 pounds, and we can get there by multiplying this. So we are going to choose option C right here as our answer for this question, because it would be 2,000 multiplied by the number of loads, and that would equal our total weight. If we move on to question 2, we have members of the band selling juice and popcorn at a college football game to raise money for an upcoming trip. And so they raised $2,000, and then the amount raised is going to be divided equally amongst those students. So which equation would represent this amount that each member receives? That amount is then going to be that 2,000, and since we are splitting this, we are dividing it equally. And so we are dividing that 2,000 by m numbers of students or band members. So Tyler needs to complete this table for his consumer science class. He knows that 1 tablespoon has 3 teaspoons, and 1 cup is 16 tablespoons. So a teaspoon there's 3 of them in a tablespoon. So I'm going to write this in my column here. I need to multiply, there are 3 of these, but teaspoons are smaller. So we're actually going to divide by 3 if we're moving from left to right here. But we would multiply by 3 if we're moving from right to left. And now a cup contains 16 tablespoons. So actually it might make sense for me to write these rules out from right to left. Each cup I can multiply by 16 to get the number of tablespoons, and then each tablespoon we can multiply by 3 to get the number of teaspoons. So if we need to go the other direction, we'll just divide by those numbers instead. So let's do that with our first row here. If we take 2, so this 2 right here, and then we multiply it by 16, that is going to give us 32. So we will have 32 tablespoons. Then we're going to take our 32 and we're going to multiply that again, and this time we're going to multiply it by 4. Or I'm sorry, by 3. I don't know why I said 4. So that would give us 96 teaspoons. Now for our next row, we have these ones, so we can check, is it dividing by 3 to get to our column to the right? It is. So we want to divide by 16 to get the number of cups. And so if you can't tell already, that's not going to be a whole number because 12 is smaller than 16. But if we reduce this, 12 over 16 is actually going to become, because we're going to divide by 16, but this is going to become 3 over 4. Or if you plugged it in your calculator, you might see that it gives you 0.75, but this is 3/4 of a cup. And for the very last row, we're going to multiply going from our right to our left. So we're going to check, is this multiplied by 16? 3 times 16 to make 48. That does work. So now we're going to use our rule of multiply by 3, take our 48 and multiply by 3 here. So 48 times 3 is going to give us 144. So this would be 144 for this spot in our table. So part A was to just complete those missing values, but we have a part B for this question too. So that is to write an equation that represents the number of teaspoons contained in 1 cup. So we want to know what a cup is equal to in terms of the number of teaspoons. So the number of cups would be equal to, well, the number of tablespoons, but we're going to multiply, I'm sorry, not tablespoons, it is still teaspoons. So we are going to multiply by both of these numbers. Whatever our cup number is, that would be multiplying by those. But if we have teaspoons and we're moving to cups, the number of teaspoons would be divided by both of these. So since I'm representing cups as like a whole number here, we're going to take teaspoons and we are going to both divide it by 3 and by 16. So that's going to be the same thing as 3 times 16, which is 48. So we would be dividing by 48 to get our number. Now, if you're not sure, you can always check starting with a value of t. So if I start with I want to check is 3, I'm going to use the values at the very bottom row of my table. Is 3 equal to 144 divided by 48? Because I want both sides to be equal. So if we take 144 and divide it by 48, we check, yep, I get that 3 is equal to that amount, so that works. You can also check with the top row and check if 2 is equal to 96 divided by 48, and you would get that is true as well. So since they wanted this one, the answer to B cups, that's why I have it solved for C, but it is still equivalent if we say that the number of teaspoons is the number of cups multiplied by 48. These are equivalent equations. So they represent the same thing, they're just reorganized. But I would still say that the answer to this one is probably C equal to T divided by 48. So that's the end of the first page. We're going to flip over to the back. And we only have questions 4, 5, and 6 here left, so it is just one page front and back. So for question 4 here, it is possible to make some pretty easy mistakes like we could have made on the question before. So for question 3, we actually had the same sort of thing, the conversions. We're going to talk about those again, and I actually frequently mess this up, so I am going to make a table. They actually recommend you do that for number 4 here. They say try creating a table. That way we can always just check that our conversions work. So for the volume of dry goods like apples or peaches, we can measure it using bushels, pecks, and quarts. 1 bushel contains 4 pecks, and a peck contains 4 quarts. So even though it is tempting to say that like B is bushels and that's equal to 4 pecks, that's not quite true. In terms of mathematics, we're not going to multiply the 4 with the P. We're actually going to multiply the 4 with the B to create the number of pecks here. So table is the easiest way to explain this. And so that's what I will do. We're going to make a small table. And then using that, you can kind of see how the values will change because it is really easy to misinterpret this question. So we're going to say a bushel, a peck, and a quart. So in the 1 bushel, there are 4 pecks. So to get from 1 to 4, I'm going to be multiplying this number by 4. So it's not that 1 bushel is equal to 4 pecks, it's that there are 4 times as many pecks within 1 bushel. So I'm going to fill out just some relationships here, and then we'll actually use some mathematics to fill out the rest. So they said 1 peck contains 8 quarts. So what I'm doing here is I'm multiplying by 4. And then what I'm doing here is multiplying by 8. So in order to fill this out, I can keep going and multiply here by 8 to get the number of quarts. So 8 times 4 is going to give me 32. So I know that in 1 bushel, there are 32 quarts. But just like in the previous question, that 32 is going to get multiplied by the number of bushels to equal the number of quarts. So even though a quart is smaller in measurement, there are a larger amount of them. So this would mean, like if we checked it here, we would have like 32 for the 1 bushel is going to equal 32 in terms of quarts when we plug it in for that top row. Now, for the second row, we didn't actually fill in a value here on the very left. Because we're going backwards to fill this in, we are going to divide by 4. So this becomes 1 over 4. And if we checked this one, this would be 32 times 1/4, and we would want that to be equal to our quarts, which is on the other side, which is 8. And that works out as well. 32 divided by 4 does give you 8. So the relationship here, even though it's might seem like we should do multiply, it's 32 times the number of bushels would create the equal number of quarts. So that is it for question 4. Question 5, we have, Priya hosting a poetry club meeting this week and plans to have fruit punch and cheese for the meeting. She's preparing 8 ounces of fruit punch and 2 ounces of cheese, and there are 12 people in the club. So 8 ounces of fruit punch, 2 ounces of cheese, and 12 people in the club. Now she's going to be shopping on a budget. So a package of cheese is 16 ounces and costs $3.99. A gallon of punch contains 128 ounces and costs $2.50. So in terms of variables, we're going to say P is the number of people. F is the ounces of fruit punch. And C is the ounces of cheese. And then B in general is going to be her budget in dollars, or her total cost, or what she would need to budget. So let's look at all equations that could represent these quantities and constraints. So if F is equal to 8 times 12, well, F is representing the ounces of fruit punch. So does it make sense to use 8 times 12? Well, she has 8 ounces of fruit punch per person and 12 people in the club. So that does make sense for us on this one. So I am going to circle this one and say, yes, it is 8 ounces per person, and there were 12 people. So that's why that one works for us. Now C represents the amount of ounces of cheese, and they're saying 2 times $3.99. Well, $3.99 is not the ounces of cheese. That was a price. So I should not have dollars in here if I'm just looking for an amount of cheese, unless I'm like dividing. So B is not going to work for us here. C says that 2 times $3.99 plus $2.50 is equal to B. So it's okay for our dollar amounts to be in here because B was also the budget in dollars. So that's okay for us to be using our prices when we're talking about the budget. So 2 times $3.99 plus $2.50. Where is she getting that amount? Well, that's the $3.99 for the packages of cheese, and then the $2.50 for the gallon of fruit punch. So if she has 12 people and she wants 8 ounces, is 1 gallon going to be enough? Because she's only buying, according to this equation, 1 gallon for $2.50. So 12 times 8 is I want to say that's 96, but I'm going to double check myself on a calculator here because, 12 times 8 is 96. So yes, she's going to buy a gallon and have 128. So the 250 is going to be enough. For $3.99, that's 16 ounces of cheese. She wants 2 ounces of cheese per person, and so there's 12 people. So for each of those 12 people, we would have to do 12 times the 2 ounces each to get 24 ounces. So yeah, she would have to buy 2 packages of cheese because one's not going to be enough. That would be her total budget, is the number of items multiplied by their price. So C works. Option D says that 2P is equal to C. So we are going to have 2 ounces of cheese for every person, and that is going to equal the amount of ounces of cheese, which is going to be correct. So this one is also correct. We have to double the number of people, and that would give us the ounces of cheese she needs to purchase. And then the last equation here says 8F, well, that's 8 probably ounces of fruit juice that it's talking about, and 2C, that's not going to equal our budget because these are just amounts and not dollars. So E is not going to work for us here. It's just going to be A, C, and D. So then our last question here is some review of exponential stuff. We're looking at the number of people with the flu during an epidemic. That's going to be a function, F, of the number of days, D, since this epidemic began. And the equation F of D equals 50 times 3 over 2 to the power of D is what defines F. So they're asking us a few things. How many people had the flu at the beginning of the epidemic? Well, the beginning, that is going to be our initial value, or if you plugged in 0, and in this case, that is going to be 50. So F of 0 equals 50. This is the initial value of the equation. Or you could just plug in 0 and actually plug it into a calculator and see what you get. So question or part B of question 6 says, how quickly is it spreading? How quickly is the flu spreading? And then we want to explain like how we know. That we're going to use the growth factor for. So 3 over 2 represents how fast it grows or spreads. It's not growing, it's spreading. So that means 1.5, because 3 over 2 is 1.5, times as many people are sick each day compared to the day before. And we know this because this is the growth factor. That's why I wanted to say it was growing. Okay, so then parts C and D are just going to ask us a couple things. What does F of 1 mean in this situation? It means the number of people who had the flu is not glue, the flu, after 1 day. And then they said, does F of 3.5 make sense in this situation? That would be the number of people who have the flu after 3.5 days. And yeah, this definitely makes sense. So F, we'll say yes. it is the number of people who have the flu. I keep on writing flu with an E. 3.5. Let's write legibly, please, Ms. Bowman. 3.5 days after the epidemic began. Now, if our number was a fraction amount of people, then that would be different. But in this case, because the 3.5 is representative of how many days, we can definitely measure things in half a day. And that is it for our assignment. So thank you for sticking with me on this. And this has been Unit 2, Lesson 3, Cumulative Practice Problems for Illustrative Math, Algebra 1.